Hello everyone and welcome back. So this is the result of a flipbook capture from OpenGL, Houdini OpenGL, and I used a 1024 resolution to make sure that I capture everything, and I'm pretty happy with the result. I really like how we're getting these nice wispy details as well as the emission and fire and everything. I think it's working really well, and we're getting high resolution. It's super fast to sim, and that's how you get your first sim in Houdini. Alright, so this sim that we didn't inject velocity. Remember when we set up the volume source, we had density, temperature, and velocity, and we want to create some velocity so that the source has some force. Right now everything is coming from the microsolvers as well as the temperature field, which causing it to rise. So let's do that. I'm gonna go back to the source here, and because this is a volume, it's going to be hard to compute a velocity field that matches the movement. So what I'm gonna do is I'm gonna copy this and plug it into the original geometry. Okay, so this is my geometry, and I'm going to fill it with points. So VDB from polygon, or we can use this one. So this is the volume, okay? And I'm gonna scatter a lot of points in there. And I don't need any relaxation, just points. I'm gonna put 5,000 points, 8,000 points. Cool, and now if I plug them here, we get the deformation that we want, and then I'm gonna use a trail node. Trail node will be able to compute the velocity on these points. So compute velocity, and if we display it, we get this vector. Cool. What I want to do now is convert this into a volume. So we're going to use a volume rasterize node. Volume rasterize attribute. I always get confused. So the attribute that we want is V. The coverage we want, it's okay, we can create an attribute called density. So I'm going to put down a wrangle node, and I'm going to create f at density equal 1. And the attributes are density, density and V, because we need the density for this thing to work. And then I'm going to lower the particle scale to 0.1. And if we middle click, we should see a density field and a velocity field. We don't have to sample the attribute, but it's good. It's better to have it so that we can rasterize it and use this coverage attribute. If we don't have it, then the result is going to be a bit off. But I mean, this is going to work fine as well. But to make it look proper in the viewport, it's better to have a density attribute. Now these two will not be 100% the same, in terms of result, but because we're going to tweak the particle scale to give us the result that we want here. I'm going to lower this to 0.5, and now we have a density field and a velocity field, and all I care about is the V. I'm going to name it vel instead of actually no, we're going to keep it as V. It's fine. Yeah, it's easier this way, and I don't need the density field, so I'm gonna blast it. And I only need the velocity field, and it's a vector field. See vector 3, and I'm gonna merge it with my result here. And to keep everything consistent, yeah, these two volumes, to keep everything consistent, we have to make sure that they are all VDBs. Okay, in some cases, if you use volume Houdini native volumes, you will have VDBs. You have volumes and VDBs. It's better to make sure that everything is of the same format. So in this case, it is. And let's go back to the sim pyro. I'm gonna lower the resolution to 0.6. We're gonna keep everything the same. And let's go to the source and see what we have. We already have this set up correctly, so it's looking up for a field called V, and it's putting it into the target field vel, and this is what the pyro solver will be using internally. It's called the it's called vel. The attribute name can be anything, but in this case, because of the volume rasterized node, the volume attribute rasterized nodes, it's called V. I'm going to use that as the default. So I'm going to scale this to 100, and we should see the smoke shooting out very, very fast. Okay, so 10 is good. But what's happening right now, it's the smoke is pushing in the way, in the direction of the object. I don't want that. I want to negate it in the opposite direction. So minus 10, so it leaves a trail behind it instead of pushing upward. And it's still very high, so I'm going to lower it to -1. I just want a little bit of kick in the beginning. Yeah, you can see how it's behaving in a nice way now. I think it's still strong. But we will keep it like that. And let's go back here. And I want to add a little bit of randomization to the velocity force. We can do that using a volume velocity node. So this is my volume. This is my V. I'm going to plug this node here and go to the curl, and I'm going to add curl. You can see it's changing the value. One way to visualize this that I like to use is to put down a scatter node and scatter points. Not on this one. I can scatter points here, and I don't need them to be organized. And then I use a volume trail node, wants points, and then a velocity field. And make sure it's using the V, and that's how the velocity field is going to look like now. If I disable this, you can see it's just a circular motion, and if I add the volume velocity node, we can break it up, and we have to make sure, yeah, it's adding. Cool. So yeah, it's adding. I was worried that it may be overriding, but it's adding. So I'm gonna do it like that, and then it changes over time as well. So this velocity is gonna change, and that's the result we're gonna use instead. And I'm gonna go back to the resolution, increase the resolution to 0.03, and run another sim, call it with vel. And I want to do one more thing. I personally don't cache velocity. We don't need to cache velocity at the moment. We're going to talk about this later, but for the sake of practicing right now, we're only going to cache density and temperature and flame, and I'll explain why flame later. So the field is called flame, and it is invisible as well. I'm going to save this to disk, and then I'll do a viewport capture like this one and continue in the next video. Thank you guys for watching, and see you in a bit. Bye bye.